Yes, we're recording. Okay, what's up?
What's up,
Friday.
Austin?
Happy Bowtie Friday. I'm here with David Myhall. We're
I
gonna
got
talk about a permit playground. You're flopping and popping,
I got the bow tie T-shirt look because
which is a
I don't have
classic look. Classic look.
I don't have the awesome fashion sense that you do. So just gotta make a T-shirt.
Like I said off camera, my wife went shopping for me, so I got lots of fancy shirts and ties now. I'm set.
Nice.
Okay, so permit. We're talking about permit on DAI. So let's see. The current DAI contract DAI is a stable coin on Ethereum. I don't know if we have to start that far. Made by maker on your shirt, right? There we go. Okay, here's let me just share my screen and we'll look at the DAI contract real quick. So here is the DAI contract deployed. We're looking at it on Etherscan. Gooey dooey. Okay, so let's scroll down to the code because this is deployed.
I'm distracted by the price.
Yeah, I know.
We're here for the tech.
That's
we're just
right.
here for the tech.
We're here for the tech. Okay. How much money is in DAI right now? Maybe that is a good. Can we?
Go
like,
to DAI Stats. Go to DAI Stats. DAIstats.com. That's Mariano's website.
Oh, nice. There we go.
Oh wow, they changed this UI. Okay, so there is. That's a lot of
million. Right?
Is that?
Wait.
400 million DAI, but that's not how much money is in DAI. So there's over $1 billion of collateral in DAI.
Okay, right. So you put in ETH and you over collateralize it, and you get like 60% of that ETH back in DAI. Your ETH stays locked up, your DAI stays stable, and as long as the price of ETH doesn't go so far down, you don't get liquidated, right?
Yeah. And the nice thing when the price goes up, like it's been doing this week, is like, for me, I'm like, I can just make more DAI now.
right.
So that's true. Cool. But I guess, the problem that we're trying to like address with this is, if you've used these Ethereum dApps, you'll know like to use any dApp that uses tokens, you have to do this like approve function. So like if you're going into Uniswap and you want to like, say you want to sell some DAI for ETH, when you go like, I want to sell DAI, it's like, all right, you have to like unlock your DAI, you have to approve your DAI. And so you got to like do this approved transaction. You got to wait for that to pass. And these days with the gas prices being so high, like that means you're paying like, I think I've paid like $5 to unlock my DAI, or to unlock some new token. So if you have like just a couple dollars worth of DAI, you're going to spend more money just unlocking it than actually swapping it. So thankfully, like the new version of DAI, they added this permit function, this like new way to approve without sending a transaction, with just like signing a little message.
Exactly. Like the user experience here is key. You can get just a simple signature from your user, and you can do everything in the background, moving their DAI around for them. There's just some trust there, right? They have to permit some address to move their DAI. And obviously that's probably not going to be like an end user account. That's what EOA? What's EOA?
EOA, Ethereum ETH only address.
Externally owned address?
Or maybe it could be either.
Externally owned.
I think you might be right.
An EOA is just like I have a key pair and I can sign things and those things can go on chain. But also smart contracts have an address, right? So you can basically approve some second smart contract, and as long as it's well audited, that's going to move your DAI. And it's just like, so you basically you trust the DAI contract, but now we're talking about trusting a second contract. So as long as that second contract is solid, this kind of, you can kind of trust that sidecar. So they just sign something that trusts that sidecar, and then that sidecar can be moving around their DAI for them without them having to make a transaction, them having to worry about block times and all the other junk, right? The account can simply own DAI and sign messages. They don't need ETH for gas or anything like that, right? I think we've covered the why. Definitely covered the why, right? That's like great UX for a user. When they walk in and they're like, oh, I'm going to invest $100,000, sign a message and walk away, right? That'd be pretty rad.
Yeah. Yeah, and the sad thing is, like, I haven't seen very many apps using this so far. Yeah. Well, you know who is using it is Uniswap is using it.
Okay.
The Uniswap LP tokens. So if you put money in a Uniswap pool and then you want to take that money out of the pool, it'll do this to let you take money out of the pool.
Okay, so it's not the DAI contract. They put a
no, because they don't control like the token contracts, but like the Uniswap UI and the Uniswap tokens. The Uniswap tokens represent like the pools.
So
those
that's
work
something
together.
we should talk about too, is there's actually kind of two different permit standards that are happening right now, right?
That's right. Yeah. So Maker was like kind of the creator of this idea. So when they came out with the new multi-collateral DAI, they're like, hey, we created this permit function. It's really cool. It lets you do these cool things. And people liked it. And I think, I'm blanking on his name. The guy who actually created it, he went on, Martin, went on to create an EIP, like basically trying to standardize, saying like, hey, everybody should do this. Like, if you want to use permit, this is how you do it. I think it's EIP.
But it was missing
12.
one little weird thing, and the way he built it, and he showed it to me, and I don't know why I didn't say this at the time, but you basically allow all. I may have even said that at the time, and I think his answer was there will be these sidecar contracts that. But basically, when I permit something, I want to permit $200 and no more, right?
Not
but the current
dollars.
state of the art is like, we'll permit infinity of your DAI, and that's just how like you go to any DeFi platform or any decentralized app, and it's always you're going to do 2 transactions. The first transaction is going to be giving them access to all your DAI, and then the second transaction is going to be moving some small fraction of that DAI around, right?
Unless you don't. But
let's get into this.
Yeah, but just to wrap up that side is that there are 2 different versions of this standard. There's like basically there's the DAI version, and then there's like the everybody else version. But since DAI is like the most popular token on Ethereum, like there's a good chance you might be using that. It's good to be aware of both of these. And as we'll see in a little bit, the library I made has 2 different functions to support 2 different types of permit.
And the goal here is we would like to give you the scaffolding to be able to build a decentralized application, to be able to talk to these permit functions very, very easily. And I was like, oh, I'll do a demo build. And then you came out with eth-permit, which is an NPM package that's going to make this even easier. And so we'll pull that into scaffold-eth today and see how it works.
Awesome. I'm excited.
Cool. Yeah. All right. Let me share my screen. Okay, cool. So here's the DAI contract. Whatever millions of dollars are locked up to mint these DAIs, right? But basically, here's this permit function, and we don't want to steal all of their code with their WADs and their vals and their dests, but we will steal this permit contract and we'll bring it into a test DAI contract that David, you built before this call and just kind of sent over to me.
Yeah.
So go ahead.
I guess it's already there, so I know we can. You can paste it over that, but the code's...
No, it's here. It's here. I pasted it in.
So what this contract is, it's basically, I took the Open Zeppelin ERC20. I assume most devs know the Open Zeppelin, but Open Zeppelin, they're just like a bunch of like templates and libraries for building contracts. So the Open Zeppelin ERC20 gives you everything you need for like a simple ERC20 token. We take that and we like add this permit, which is literally like copy and pasted from the DAI contract. So now we have an ERC20 with permit. And then the only other thing is it mints 100 tokens to the creator. So like, this is not like a...
right here.
This is a test token.
We see, okay. So it sets up that domain separator kind of namespace variable, and it mints 100 to whoever the deployer is. Got it. One other thing we should probably talk about, and we already noted it, but we should show it right here in the contract, is this approve. This is how much is allowed. And it's uint -1, which is 0 minus 1, which causes underflow, which is basically the largest possible unsigned integer, is what you're approving by default.
Definitely not
just setting
intuitive.
That to true. Yeah. Yep. Just pointing that out because that's kind of a weird.
If you see uint -1, it means infinity, basically.
Yeah. There you go. Perfect. So there we go. So we basically have an ERC20. And we've carved out the permit function from DAI, and we have that here. So we basically have a test DAI, like a test DAI that we can play around with. And let's compile that, right? Okay, and so, and I also brought in scaffold-eth. So if you're not familiar with scaffold-eth, it's basically just like some scaffolding. It's a stack that I use for building decentralized applications. It's comprised of basically Bidler and create ETH app with some extra fun stuff that I've added in, and it's just a bunch of components that I use all the time. So I started with scaffold-eth, which basically you have a web server, you have the Bidler blockchain, and now we can yarn run deploy here, and this will compile and deploy all our contracts. And then we'll see this address right here change as it injects the new contracts in. Okay, so we have your contract, which is the contract that comes with scaffold-eth, and we've got this test die. So what you can do over here in your app is you can grab this contract object, and we can bring in test die. Ooh. And then we'll be able to kind of like just see that it'll just parse the ABI automatically, and we'll see all the different functions we get from test die. So technically this is an ERC20. We could probably see that the owner has 100. Let's see, who would be the owner? That's gonna be
the owner is whatever account it came
from. Yeah. Let's have it actually just mint a bunch to austingriffith.eth. That'll be even easier. So let's go to our contract.
You got to
instead of we're gonna do a centralized pre-mine. Are you ready?
Ooh. I'm not investing in this coin.
This is trash.
This is not fair.
Yeah. Okay, let's try that again.
Pre-mined scam.
Pre-mined scam. Oh man, the trolls have gotten to us. Okay, there we go. So we're gonna redeploy the contract, but this time my fake die, instead of sending 100 to the deployer, which is like the Bidler 0 account, I sent it to austingriffith.eth. So now if I go to austingriffith.eth and I paste this in here, we should see that I have a balance of 100. I got 100 die. Yeah. All right. So now what do we want to do? We want to permit. So if I was going to build permit, I would go grab this hash, and I would, as a developer, have to figure out how to get this hash just right. And then I need to sign it with my MetaMask, right? So to get that hash just right, I would carve that out and put it in another contract and have a read function that does a get hash, and then I'd sign that. But you've taken care of all that. I don't need to do that stuff.
I did all the hard work for you.
You did all the hard work.
You don't got to worry about hashing and signatures and all that. Like, just pop this library in, and it's like a one-liner.
It's figuring out like getting signatures to work right on Ethereum is pretty hard. Like doing meta transaction stuff,
oh, yeah.
You just like have to try it like 6 different ways. Like, do I need to have that string in front of it or not? Like, so much junk you have to do.
And then again, especially with this, like this is the new type of signing messages, like the typed sign, which is why like it's got like a nice little UI.
Oh, it's even fancier. That's right. You're not just
fancier, but it's like it's even more complicated because it's newer, and that's why like again we tried to make this video last week and it just didn't work. So I have to like had to keep hacking away at that. But
yarn add eth-permit, right?
Yep.
Here we go. Here we go. Bringing in eth-permit. So we've got scaffold-eth, we've got eth-permit. I think we've kind of covered all that. This should be pretty easy to just Google up and find. Hopefully we'll just end up with like some kind of a branch here that we could just hand out to.
Yeah. It should be quick. eth-permit's like a super light library.
There we go. Okay, so we got eth-permit 1.7. Okay, now let's see what kind of docs you got here. All right, cool. Oh, you've got the die style and it's called 2612, huh? That's the
ERC2012. Yeah, so I guess if anyone's like really curious, like wants to dig deep on like how permit works, you can read ERC2012. There's like the whole documentation and the standardization, and if you're trying to make a token that includes permit, like you should probably read up on ERC2012 and like copy their code. But for now, like let's just consume. Let's just do the dApp side of it. Let's just permit some tokens.
Yeah, the thing is, I don't want to go through it, right? If someone else has already done this and been in the trenches and figured out how to get the signature to work, thank you, David Myholm. Okay, so I'm going to put in a button. We'll just put in a button to start testing this out.
Yeah.
And we'll call it permit. Whoa, get out of here. Okay, and then on click, we will call your function. Better make that a function itself.
Yeah.
All right. So, and then we'll maybe, let's see, console log the result.
We got to change the params a little bit there.
We'll need to set some stuff in here.
Yep. So window.
So let's see.
So the first parameter is, so you can change that to a user provider, I think.
Yeah. Yep. So in scaffold-eth, there's a couple providers. You've got your mainnet provider that's always connecting to Infura and Etherscan and stuff to get things like ENS and whatever's on the mainnet. Then you've got like a local provider that's either going to be talking to your local node or if you happen to be deploying this to mainnet, this would also just be equal to mainnet, but right now it's local. But then there's a user provider that's going to be using whatever this user has here. So I can log out and scaffold-eth is just going to give me a burner. If I copy this address and I paste it in here, I'm going to get another user provider. So there's this provider here that's connected to whatever local network you have that is actually an account that is like a burner, and you can send money to it from the faucet, and then this guy can, you know, make transactions. And he's just talking to the local chain. So that's the user provider, and that's what we'll be putting in, and this should change.
I will say the user provider does still have to be on the same chain as the token. I think it already is.
Yes.
Yeah.
Yep.
Because
That's a good
read
point. Yep.
It's going to read some
provider is
some
a little
properties
tricky because provider is kind of like an old Web3 word, but really in
not old.
JS, well, old. That's not as old as me, Sonny. No, but it's like it's traditionally we thought of a provider as kind of like what MetaMask is, but really in ethers you think of a provider as more like the connection. So I have a provider that's talking to Infura. I have a provider that's talking to my local node, but then I have a signer, and the providers and signers can be combined in one, but a signer is basically like a key pair, something that can sign transactions. So you use your signer to sign transactions and you send them through your provider to the chain. Nomenclature. Okay, but yes, all of that just to get this user provider right here, and we'll plug that into here. So what we're saying is using this connection to this blockchain and this private key, right? Mm-hmm. Okay, yeah. So token address, that's got to be our DAI token, right?
Yep.
Okay, and that is this address right here. And you could get that, that's in your artifacts too, if you wanted to go look at it. Oh, actually, you know what we should do is we should just do, I think, do we have read contracts here? We could actually grab that address from, yes, we have them. Where do I have them? Oh, it's probably in there. Okay, no, never mind. Let's just do it this way. This is easier. Okay, so we've got our token address and then our sender address and our spender. So we've got a sender and a spender and a token. Okay, so the sender will be me, right? Will be the, since oh, let me connect back up.
Yeah.
Since I own the 100 DAI, let's go look. Yes, okay, so I'm the sender and there's a spender. Maybe it should, I don't know, whatever. We can, it doesn't matter what it's called, what the nomenclature is. So this is more like the owner's address, right?
The, which one? The sender address?
Yeah. I'm calling it owner.
Owner. That's fine. Yeah. That makes more sense.
Right. So you have the guy who owns the DAI, and then you have the guy who's spending the DAI on behalf of the owner.
Yeah.
Right?
Yeah.
And then the spender, who's the spender going to be? That's probably going to be our other contract, really.
Yeah.
Technically, you could sign some other account to move your DAI around, but it's really not what this pattern is for. We have the super secure DAI contract, and you're going to be approving some other thing, full access to it. So that other thing better be pretty darn secure. So let's actually set that up to be this contract. However, there's no functionality in this contract to move the DAI. So we're probably going to need to bring in like an ERC20, like the interface in, right?
Yeah.
Okay. So let's see. What's the best way to get started with that? Well, let's just do the permit, right? Let's just do the permit.
Yeah. Okay.
So our spender. Well,
let's try this, and then we're gonna log the result there.
Oh wait, doesn't like that. Right. Exactly. Let's just get something back from your library first and see what.
Yeah. Exactly. And we'll get to see how MetaMask handles this and everything.
Yep. Okay. So this will be the spender too. So we've got our fake DAI, we've got my address that has 100, and then we have another contract that we want to permit to send the money around, even though it can't do anything. And we have this permit button. So let's bring up the inspector here and see what happens when we do a permit. Uh-oh. What?
Have you installed? I think you might need to reinstall and get the newer. What was the last time? Oh no, you did.
Yeah, we did. Yeah, we just did it.
Oh no.
Let me.
Can you check what version?
Yeah, it's 1.7.
It should be, right?
Yeah.
I saw it say that.
Yep. eth-permit 1.7. That's the most recent, right?
Okay.
Oh wait. Yeah. I mean, it's going to be in the package. It's going to be in this package JSON. We should see eth-permit. Or yes, it's there.
Permit 1.7.
Yeah. So we're in
Wait,
start.
just try it one more time. Or the other thing you can do. No, not install. Try doing the permit. Like try refreshing the
Oh, okay. Yeah. Let me bring. I just killed the whole app and brought it back up.
Gotta bring it back up.
Just in case.
Must not be a non-empty string.
Something about args method. Does that look?
Yeah,
familiar?
this is like ethers stuff.
Okay.
Let me just check that I actually published this.
npm publish. Okay. Yeah. Let's see.
So if this the workaround is we can just do window.ethereum for the provider.
Okay. So there's something weird with ethers right now, but if we put in,
yeah, I got it working before. Yeah, I'm not sure what's up with that, but
the window.provider is just going to use the injected MetaMask.
Sorry, no, window.ethereum.
Oh, sorry, yeah, I did that wrong. Is that because MetaMask can be used on other chains? Like why the .ethereum? Whatever. Okay, let's try that. There we go. There we go. Okay, so this is what comes up when you call a permit. We can see these specific addresses, right?
Yeah. So I'll say like the cool thing. This is the typed sign that we were talking about before. This is like the new way of signing messages. So you might have seen in the past on some dApps, it's like, hey, sign a message, and it just shows you a bunch of like random hex characters, and you're like, I don't know what I'm signing, but like whatever, it told me to sign it, so here we go. This new type sign, it lets you see like, hey, like I'm signing a message, like here's the data that I'm signing. Like it just gives you a bit of information about it. So that's the cool part of these new signatures. But again, this is kind of like a new one. The reason that we're running into these issues is because this is like a new way of doing things. I don't think it's even been fully formalized yet.
So yeah, we can clearly see that we're giving whoever this spender is, we're giving him full access to our DAI. Yeah. Instead of just signing some random hash that you have no idea what that is associated with. So
you just hit sign, and now you can see in the console here.
There we go. Okay, so
this gives you everything, like all the info that you just signed. So it's got some things like the expiration. That's basically like a timestamp, and it's again the timestamp is infinity. Like this will always be valid. It gives you a nonce, and the nonce is like
replay protection.
Replay protection. Yeah, it's like if you sign a bunch of permits and they all have the same nonce, like only one of them can actually be used. The important things here are the RSV. You see those, right?
Mm-hmm. Yep.
Yeah, and so RSV, that's like the typical. How do you explain RSV? This is the signature. This is the. Oh man, do you know like more about how to explain the cryptography behind that? This is what's the name of the signature? What's the name of the Yes. Yeah.
We are experts.
Well, the nice thing I think about like
ECDSA.
ECDSA. The nice thing I think about like where as blockchains and cryptography.
Yeah, you
like,
just got to show this curve right here. This is all you need.
Yeah, oh, and now it's super simple. Now that's obvious.
You guys all get
it. It's just it's just like a vase shaped curve, and that makes sense.
It's a vase. Ooh, a fine vase.
Laying on its side.
Yes.
But I say like the nice thing is like you don't really need to understand the cryptography these days, right? Like I don't understand this cryptography. I just know like sign a message, and that message like has a signer, and you can check if it's valid or not, right? So
this process is where the public address is derived from the private key, I think, right? Like the path that you're tracing is your private key, and where you end up is your public key, and it's one directional. It's like the way it's derived. I think. I don't know.
Sounds good to me. I'll believe that.
But that private key can then be used to sign things. And really, if you're interested in signed messages, you should go check out the ETH build section on the key pair, because I go through like actually signing. I take a key pair and I sign some message, and then I recover that message. You can kind of like do that very visceral plug and play. Yeah. So
in that ETH build example, you probably had a signature as just like one long string.
Yes.
Right.
Yes.
So
the difference between RSV. Yeah.
Yeah, it's the same thing. It's like you can literally like chop up that long string, and it's got like 3 different numbers in it. But yeah, we're using it like split into 3 different numbers instead of squished together into a long string.
And sometimes you'll see in contracts that they do actually just accept the signature.
Yeah.
This is the gas intensive, lazy way to do it. This is how I do it.
Yeah.
I just say, send me that signature and I'll handle it in here. And what
And I'll
it
split
does
it.
is
That
it
code you're
cuts up
selecting. Yeah.
the code, right? The code cuts up the RSV into the pieces. But yeah, you can do that off chain and save a
The
little
better
gas.
way, the more like official way to do it,
Yeah.
is to just do like this RSV. So we've got this RSV and we've got some other data, and what we can do with those values is now we can call a function on another contract and give it those values, and then that contract will call permit, and it'll give itself access to our tokens.
Which is this second piece that you have here, which is actually
well, so this is just calling permit on the token itself.
Right,
so we can do
token.
this.
Yep. So what
so
I
you can do that
is
if you call permit like yourself, like you can do it, and it's not a bad idea to like play with that to test it out. But if you just call permit yourself, that's basically the same thing as calling approve. Like you're not really saving any, like you're not making it much easier for the user. You're actually giving an extra step for the user, and they still have to spend the same gas. So really, like the exciting thing with permit is like giving this value to another contract and letting that other contract call permit. And I think that's what we're gonna do next, right?
Yes, I think that's what we should do. So what I'm going to do is bring in a special hook called contract, use contract loader, and that will load up our contracts. Actually, let's load it up with the user provider so we can talk to them. Okay, so that, oh wait, we want to really, let's see what happens. Okay, so we're going to bring in a hook that has our contracts, and let me just go ahead and console log these here just so we can see them, make sure that we have them. It should just be an object with the contract. Oh, got to bring that in here. Some handy hooks. Oh, whoops, result. Get out of here. What am I doing? Okay, well, let's go ahead and just comment that out there. Okay, there we go. Now we should, when I hit the button, just be able to see what our contracts look like. And we do. We've got test die and we've got your contract. Okay, so what we can do now is say our token address now is contracts.testdie. I think it's underscore address. Oh man, that might be wrong. Let's see. Test die. I don't see it at all. Weird.
Oh boy.
Yeah, that's really.
Oh no, it's address. It's just address, no underscore.
Just address. Okay. Yeah. Cool. So that's our test dry address, and our spender will be the your contract. Okay, cool. So now we have, and then the owner is me, and we have austingriffith.eth hard coded here, and so really we're set up now. Let's try.
We still need the signed die permit.
Yeah. Yep. I just want to kind of do it one step at a time now. I should get the signature, make sure all the addresses are right. I hit sign, it goes here, everything looks good. Okay, now we're ready for what we want to do next is send something to, okay. Let's do this. Let's get in here. Let's do a console log, just to be flagrant. Okay, so I'm going to bring in Bidler's console log.
And never actually used this console log.
You're going to like this.
That's really cool. I've read about it. I'm like, I would love that.
Right here in Solidity, I'm going to do a console log of the holder, the spender, and the wad. Come on. Okay, and so instead of actually doing the approve, I'm just taking it one step further, and I'm one step back, and I just want to console log it to make sure it all works. Okay, so then we're going to call, let's see, it'd be test die contracts dot test die dot permit. And I think I'm just going to use all your stuff here. Spender, yep, that's right. Sender is different, right? It's owner. I changed sender.
Yeah. And spender is the same. Everything with result is the same. Yeah, that all looks good.
Let's see if this works. Okay, so now it should actually have me sign a message, and we're going to send it to the contract.
Is it dot methods dot permit? This is like this is an ethers thing, right?
Yeah. Right. No, I mean like that. It's that. Here we can just console log it, right? We see test die right here. It should just be permit, right? dot permit. Yeah.
So why didn't that
maybe
work?
it's, let's see, address. Uint.
No, it should. It said it. Oh, it said dot send is not. You got to get rid of that dot send probably.
Yeah.
Yep.
That's
Web3.
Yeah.
We're mixing and matching our.
Yep. We're into ethers now. Okay, here we go.
Ethers
So
land.
this is interesting because I'm signing, and then I'm putting the transaction in myself, which is totally not how you would do it, right? But we're getting closer.
One step at a time.
Right. So I would permit, and then some other account. Right, I have insufficient funds, right? Because I need to go here and I need to go to the faucet and send myself a grip of faucet funds. Now we see that go up. Okay, now we're ready. Let's try that one more time. So I sign, and then some other account, but actually me, puts it into the contract. And then over here, we didn't get the console log, but I don't think I deployed it. Okay, one more time.
But it didn't break though. It didn't break.
We're gonna the approve probably actually happened, but I want to see the console log, right? One step at a time. Okay, here we go. Permit. Yes, I do. Someone else takes that signature, puts it on chain. Oh yeah, we get a cool console log.
Ah, that's awesome. I got to play around with this more. Yeah.
So there we go. Now we know that our contract, the watt is -1, and that's right? It'll underflow. It figures that out. I think so. I think
probably yeah. Let's assume it worked.
Let's assume. Well, this is Martin's code here, man. This is like
this is someone spent like tens of thousands of dollars to audit this code, so I think we can assume it worked.
Like verified, right? What's it called when they like
audited?
No, but it's formally verified, right?
Formally verified. This is yeah. So that's even like a level above audited. Formally verified, it's like audited is like we got smart people to double check your code. Formally verified is like we got mathematicians. Like
right, exactly. There's like Austin writing code, David writing code, Martin writing code. There's yams. Then there's an actual audit. And
you put me below yams.
Come on. That's true. Well,
yams blew up.
Yam code is like
yams blew up.
Forked, right?
None of my phone. None of my codes.
Compound, M-stable, Y curve, and what's the other one? There's like 4 different projects you fork to get yams. I don't know. Whatever. Very interesting stuff. Very interesting.
We could talk about yams all day.
When there's a lot of, this is funny, there's a lot of spice around the yams, and I'm starting to recognize the pattern. The pattern is the people who are spicy about $500 million getting locked up and $750,000 getting lost. There's a camp of people that are excited and cool and a little scared, and there's a camp of people that are like pissed off about it. And the camp of people that are pissed off, almost all are not rich. Right? It's like all of us guys, they're like poor as F, just trying to get by, trying to like make something that works. And we're like, you guys quit it. And then there's like this camp of people that are just whales that are like, this is great, we're having fun.
And they're like pushing the gas prices super high. So we're like, oh, like I would love to move a little bit of Dai and be bankless. And people are like I'm so rich, like
$100 million on some yams. Yeah.
And I'm gonna spend $100 on transaction fees because I'm making like 10 times that.
Okay, so we're going to leave our console log in. We're going to have our approve. Can I even do this? I don't think it'll let me do this. So you certainly can't do strings concatenation, but I think you can. Let's see if we can put in a fourth.
Do multiple.
Let's like a fourth argument here.
You can always do.
It worked. Yeah.
It
sweet.
Worked.
Okay, so now we're actually going to do the approval, but what we need is to build something into this contract. So let's see. So there's. Let's just.
I would just import. Interface. You can just import test-i. Why don't you just import?
I'm just gonna grab a transfer function from test-i, right? Won't this work?
You can just import. You can just do like import /test-i.
Really?
Yeah.
So I go
to your contract.sol, and then just keep that, but do just import your test-i.sol.
Will that work?
It'll work.
Cool. I like it.
And so now we want to add like a function, right?
Right. Okay.
So I called mine like eat tokens or do it or whatever. Yeah.
Do it. Okay. And what we want to do is wait. So how do I create a test? Oh, I do a new test.
No, we're not
right?
creating a test out. We're just going to use that as an interface, basically.
Right.
So in the we need some parameters for do it. So we're going to give like the token parameter. So the first is going to be like address token.
Okay.
And then oh, maybe we should copy and paste this because you need.
Yeah. I think you have.
Well, you need every value for permit. So it's like you can just copy like see like holder, spender, nonce. You need everything that gets passed to permit. Yeah. You got to spend a lot of stuff.
What? No. We're just doing a transfer from. No. We're just doing a transfer from.
But you got to call permit first.
No. No. We're calling a permit. We're doing it already. We're
still calling permit
MetaMask to do the permit. Yeah, right now.
Okay.
We're already permitted. We just need our contract to send some DAI.
I got you.
Right.
So let's just do then just do transfer from. So you need the token address and that's pretty much it. So
this is our token, and it's going to be. Is it? You don't do new test DAI.
Yeah.
You just do test.
Yeah. That's important.
Address, right?
This is definitely something I could see people getting confused of because it's like easy to miss that new, but it's like completely different things, right? If you do like token equals new test DAI, you're deploying a contract. It's like the most and that's like a really expensive thing to do, right? Like that's like the most expensive thing you can do in a contract is deploy another new contract. Whereas casting, if there's no new, you're not even like doing anything.
To talk
you're
to
just
something that already
exists. You're just changing like the type. So test DAI, you're just going to put token.
Oh, you know what we need to do is we're going to have to do a little bit of a custom deployment here because we need to first, and this is a cool little learning with scaffold-eth. Right now it's doing an auto deploy. We don't want to do that anymore.
Why not?
We want to do our token because we're going to want to get the test DAI contract address and put it.
No, but we can pass that in. We can have the.
Oh, you're saying we can just be, that could be the token. Okay.
Yeah. So that's the token. And so then you do test DAI equals.
We'll do auto deploy. Yeah. Okay. So we'll have token here and that's what comes in here, right?
Yeah, exactly.
Yeah. Okay. So really, now that we have the token, we want to do token.transfer from, right? And I need to go look at the.
It'd just be like message dots. You don't need to look up transfer from. It's just like
I do.
It's just from to an amount. So it would be like from.
How do you know?
I've written Solidity before.
Yeah, but I have the memory of a gerbil. Okay, sender.
You got too much stuff going on up there.
It's yeah, right. Okay, so the sender would be the person who's approved, right? So that's me.
But you just do message.sender. It's whoever's calling this is like you're gonna take their token.
No. The sender is the person who's done the permit. It's Austin Griffith.
Isn't this the same person? Isn't this coming from? This is coming from the web app, so it's going to be the sender, right?
Let's see. We're going to call. We kind of want to do this with a second. I'm going to do this with a second address. So it's at least like not AustinGriffith.eth that's doing it, right? So AustinGriffith.eth.
But if it's going to a contract, like
something.
But if it's going into a contract, we only need one account. Like you can think of this account as like this is like the DApp contract. It's like, this is like the Uniswap. And so tokens are coming in. So we don't need 2 MetaMask accounts. We can just do this from one.
So what I'm thinking is there's one MetaMask account that is the user. And there's a second MetaMask account that is basically the Uniswap cron job or whatever that's going on, right? They have some kind of relay that's putting your meta transaction on chain.
Isn't it simpler to just pull the token into the contract though? I mean, we could do either one.
And then that backend thing is also going to call the do it function, right? The backend, so the user just signs something and does nothing else, right?
Okay.
Then a secondary account puts it on chain and calls the do it and does all the magic stuff in the background, so the user doesn't have to F with any of that.
Sure.
Okay.
Try that.
So we'll do a permit from Austin Griffith, and then we'll switch over to a different address to put it on chain and call this do it. So that means that this transfer, let's just do this, right? We could just grab all this stuff and put it right here. Sender recipient amount. That should compile, right? That's basically all we need to do, I think. Yes. Okay. So yarn run deploy. We're gonna have to do some magic here once we get it, but let's get it out and deployed, and then figure out what's next. Okay. So we're gonna need to call this do it.
The one thing I'm a little confused about is why do we even have this like year contract? Because if you're, it's like not, it's just calling transfer from. Like you could just have that new account,
right?
You could have that second account just called transfer from by itself.
Yeah, but that would be like an externally owned account moving the funds around, and while this is an externally owned account triggering it,
because we're permitting.
Is in the contract. Yeah.
I gotcha.
So like when someone signs over their life, they're not signing it over to that back end process. They're signing it over to this. They have to trust this code right here in this contract.
And that'll, like, we're making a contract that'll like kind of let anyone move code to anywhere, but you could have a contract that's much more like strict that only lets you do. Yeah, that makes
like
sense.
This amount could be like, basically it could be like a secondary signature system where you sign one thing to approve the contract, and then that contract itself accepts more signatures, and that could be like, send $20 to the XDAI bridge, send $30 to David, send 100,000 DAI to the yams, you know, all those fun things that you could do. But those could just be signatures, and there could be this account in the background running those and paying the gas for you. Okay, we are deployed, right? We got Toki. Let's see, we got Toki here. This is Toki. This is our contract. Yeah, so now we have a do it function. Okay, so really our permit is only going to, wait, why is that unsaved? I'm redeploying. I don't know why that was unsaved. Okay, so our permit function now, we don't want to do this call, right? We'll get the result here. Where should we store that? Because we need this to be a different address.
It calls permit?
Yeah.
No, but I thought that account was going to call permit.
No. We're gonna do it from a different one.
Yeah, see, that gets complicated because now we got to pass all this data to some other account.
We will.
Okay.
Okay. So I should have, so Austin Griffith should have a balance of 100, and there should be no allowance. But what we want to do is permit this contract. Let's make sure this comes up. So it should be B00. Yeah. Okay. So I'm permitting all my DAI to this contract. So now there's like a second set of solidity that I have to trust, but I trust it. And now that gives me back this information. Now the app should store this somewhere, right? Should do something with this, send this to some backend or something like that, and give the user like a double thumbs up, like, we're good to go. You're done. That's all you needed to do, and we're good. But then what has to happen is someone's got to put that on chain. And so that's going to be some secondary account, right? Let me grab this guy here. So this is now like the apps account. Oh, what? It's not showing. This isn't it. Oh, there we go. Okay, there it is. Okay, so this is the second account. That person is gone now. Oh, what am I doing? Get out of here. Send. What is this? Okay, whatever. So this is now kind of the it's not custodial is not a good word for it, but it's the dApps service account. How about we call it the service account? It's sort of like servicing these transactions in the background. So you've signed something, you get a pretty thing that says, okay, we'll take care of it from here. Now the service account grabs that signature. Uh-oh, I've lost it now. Is that it? That's not it.
What?
The signature. I'm looking for the RS&V and is that it? I'm just gonna sign it one more time.
You might have lost it when the page reloaded, maybe.
Yeah, I think we lost it when the page reloaded. I'm sorry. All right, yes, and I need to reload this. The account.
Because it reloads the page when you
doesn't reload the page. Yeah. So okay, so let's do a permit. Let's save all that information in the back end somewhere. Okay, here it is. So let's grab. Will this just let me copy? Oh yeah, that's nice. Okay, so the app should save this signature somewhere because he's gonna need it again. Then give that guy a message, say, you're good to go. Thank you for enjoying this wonderful UX. And then we'll pass it to the service account. The service account has money. Okay, so now the service account is gonna take this information and put it in, okay, so our token is this, right? And our sender.
Well, you can't. You have to call permit first. We haven't called permit yet.
That's this right here. Oh no. That's
but do it doesn't call permit. Yeah.
You're right. Do it actually right. We need to put it.
I mean, we could put permit inside do it, but right now we're just calling it directly.
Right. Okay. So the holder is me, and the spender is
the current
contract.
Oh no, the contract address. Yeah.
Nonce. I'm just like kind of copy and pasting.
Yeah, it should match up 1-to-1.
Right. Allowed is true, right?
Yeah. Will it handle Booleans correctly?
We'll find out. I mean, like, it's always going to be true, however it handles it. True should always be true, right? But it's like sometimes false is a string, and that's true.
That's true. Yeah. I don't know if it's gonna be like an error. We'll find out.
V, R, and S, and really you should have a script to handle all this stuff. But the person has signed something. Now the service account is putting this into the contract. Okay, and now we probably saw on our chain, there was probably some kind of, yep, there's our approve right there. Sweet. Okay, so now we're approved. Now the service account goes to the second. So the service account hit die and got the approval. So let's test it. Let's test the allowance of this guy from this as the spender. It should be the largest number known to man. There it is.
Massive.
Not really. Yeah.
I've never seen a bigger number.
Nobody
in my life.
Nobody knows.
Except for the total supply of yams.
Mm-hmm. That was it. Yep. Okay, so now the service account has gotten the approval, and now the service account needs to do it, which is whatever needs to happen on that contract. I like the example of going to the XDAI bridge, right? Someone could drop into a page that says, hey, you want to use XDAI? Sign this. And they sign something. And then they say, okay, you're approved. Sign this one to send $25, sign this one to send $50, sign this one to send $75, right? And you could have that like hard coded into this secondary contract. Everyone could trust it. It could be formally verified. But that's what this do it contract will do is some kind of action that actually moves your DAI around. What are we doing? We're doing a transfer from sender receiver amount. Okay, so the token is this guy. The sender is me still, right? Yep. Is Austin Griffiths.eth. But now the recipient, how about we send it to this guy? For some reason, we're going to send it to the service account. I don't know why. This could be basically anything, right? This is like the thing. This is the magic right here. Is this person is going to get DAI from me, and I didn't have to do any of it. And the amount. Wait, is this the amount we're going to send? Let's see. I have 100, right? So let's send 10 of them. Wait.
Does it have decimals or no? Is this way?
I think it's times 10 to the 18.
Okay.
Yeah, no, it's 100 ether, right? In the contract, we can find this out. Let's look.
Yeah, it's ether, but I didn't know about if your text field added the decimals.
No.
To the 10.
I mean, it usually does. If there's a text field that it detects is a uint, it'll have extra buttons for going to. Okay. But for some reason,
Gotcha.
Okay, so now let's see what happens when we do it.
Fingers crossed.
Okay, something happened.
Contract
to do it. Called.
Okay,
so now we what do we do? Let's go.
Let's check some balances.
Allowance. It's gonna be down. It's gonna be down 10. No, we're not gonna look at that. Let's go check balance. That's what we need to check. So balance of this guy. This guy should have 10 now, right? Yeah. Awesome.
Yes.
So
we did it.
As Austin Griffith.eth, I landed on this app and I signed a thing, and because of that, someone else somewhere else paid all the gas and got 10 of my DAI.
You just gave someone DAI and you didn't spend any gas money. You didn't send any transactions.
And it took us like an hour. But we got it.
We got it, yeah. I mean, imagine if we didn't have this awesome library.
Right, exactly. The library helped. We need to get Ether's providers working.
Yeah, well, they were working on my computer.
Works on my machine. Okay, I think this is basically the demo. I think we could probably build a little bit more, right? There's obviously like a lot of cool scripting that can happen from here, but I think that could be kind of handed off to the developer, right? Like,
yeah,
I think we should just commit what we have here as some kind of branch and let people kind of take it from here.
I think so. This is like a really nice primitive. Again, like this, we've given people the ability to move tokens and let someone else pay those gas costs. So you can do meta transactions. You can like do, contracts where you can do things with tokens with only one transaction. There's a lot of different stuff you can do with this. So yeah, I think this is a good spot to be in.
All right, I'm gonna call this the permit playground branch, and I'm gonna push it out there. So yeah, so we'll have like this little video, and then we'll have this branch of code. And maybe one day I'll even take this a little farther and do like a little write-up about it. But yeah, that should be good, man. Thanks for joining me for a little permit playground action. This is fun.
Thanks for having me on. I was pumped to get to use my bow tie for something.
Yeah, dude.
Even
if your shirt doesn't have a collar, you can still wear a bow tie. David Myhall has proved it.
Exactly.
All right, man. Yeah, happy Bow Tie Friday. Thanks for jamming on this.
Awesome.
I'm going to post it right now, I think.
Cool. Thanks.
Awesome. All right. See you.